Today I'm going to be presenting a model on what organizations should be aiming for to achieve when able to kind of secure their secrets within their environments. So we're going to talk a little bit about the problem of hard-coded secrets. I'll quickly explain what I'm referring to when I'm talking about secrets. I'm going to show how these are used in some high-profile instances. So how actual breaches in the real world have occurred because of poor secrets management. We're going to be going through what are unsecured development practices, and then we'll be going through what the model of a maturity model, what a mature model looks like to manage these secrets. So let's start off with the problem of hard-coded secrets. So what am I referring to when I'm talking about secrets? So I'm referring to pretty much anything that is a secret, but specifically I'm talking about digital authentication credentials. So these are things like your API keys, your security certificates, your username and passwords to, for instance, your databases. And what's specific about secrets is that these are made to be used programmatically, which means they're machine-to-machine encryption keys or machine-to-machine secrets. These give access to the innermost workings of our organizations today. So they're extremely sensitive. Oh, mood lighting. So we absolutely want to make sure that these, remain secret, but it's actually really hard to do this because everything that we use today runs on secrets. Our supply chain is full of third-party services and third-party tools, which are all leveraging these. So if someone can exploit these, they not only can get into the inner workings of your systems, but they can also poison other applications, which I'll talk about. So we know what we're talking about when we hear the supply chain, when we're referring to kind of physical supply chains, in auto manufacturing and other areas. But it's very similar for software. So you have your open source packages and dependencies. You've got your IDEs, your development environments. And then once you've built it, it needs to go into testing. And then we kind of send it out through artifacts. So this is a very nice, pretty picture of really what the software supply chain can look like. But what does it really look like in reality? Well, it gets a lot more complicated because our dependencies are dependent on each other. So it's not just a linear line. We have lots of different areas. And in between all of these, you'll see these little keys, and that's the secrets component. That's what gives access through all of these. And so if you trace back all these lines in this very convoluted manner, you will find that you'll be able to poison huge amounts of different infrastructure, systems, data by obtaining these secrets. So it's really, really important that we manage these correctly and that these don't end up in the wild. So I want to talk a little bit about, how these secrets end up out there in the wild. How do they get exposed? So we're probably familiar with this site. This is GitHub. It's the largest code sharing platform in the world. 80 million developers use GitHub to be able to publish code. Sometimes it's open, sometimes it's closed source, but it's a huge amount of data in there. Last year in 2021, 1 billion commits, or if you're not familiar with Git and that word, 1 billion code uploads, you can think of it, was made on GitHub. Out of those billion commits that were made publicly, we decided to scan all of them to try and identify if there's any secrets in there. And we found a couple. In fact, we found 6 million different credentials and secrets publicly committed to github.com. 6 million. So this is a huge amount of sensitive information. And these can be for anything. For instance, to cloud service providers, into databases, into lots of different areas. So it's a huge amount of sensitive information that's just making out there in the public web space. You don't need any authentication to be able to view this code, and it's out there for everyone to see. Other places that these secrets are really being exposed is at the end of the supply chain and in that build stage, where in areas like our Docker images. So once we've compiled our application, we might put it into what we call a Docker image, which is basically just a mini virtual machine. It contains lots of kind of different services that your application needs to run. And the problem with Docker images is that they can be convoluted and it can be quite confusing. And often people don't really understand how they work. But one thing that's very clear is that if there's secrets in your code and you compile a Docker image, there's going to be secrets in your Docker image. So there's 8.8 million Docker images on Docker Hub publicly available. We decided to scan lots of those, and we found that about 5% of these Docker images contained a plain text credential, a hard-coded secret. So that's a huge amount. And if we want to talk about the supply chain security, there was a very real threat that happened as a result of this with a product called CodeCov. They had a plain text secret in their Docker image, their official Docker image. Attackers found that, were able to turn CodeCov malicious, and then 20,000 people that were using that product had their private infrastructure breached because CodeCov had a plain text secret in their Docker image. So this exposes how integrated secrets are into that whole idea of the supply chain, and why it's so important that we work really hard in actually making sure that these remain secret and we have good maturity over kind of keeping these this way. Now, the last place I want to talk about, kind of finding these secrets is inside private repositories. So we talked about public repositories, how we found 6 million secrets in public GitHub. But you might be thinking to yourself, well, all of our source code, all of our developers, we use just private repos, right? So I don't really have a problem. The problem with private repos is that source code is a very leaky asset, and it's really bad at staying private. So we, at GitGuardian, we did some research into how many secrets we typically find in private source code repositories. So in the private version control systems that we store our source code. So if we take the average company of around about 400 engineers, 400 developers, we would find about 1,000 unique secrets in their private source code repositories. So if we break that down, we also found about 13,000 occurrences of those. So the total number of secrets, when you ignore duplicates, is 13,000. Now, if you're looking at an average company, you've probably got 4 AppSec engineers for 400 developers. That's 3.4 thousand secrets that each AppSec engineer has to go through, sort through every single year. That's an impossible job. That's 10 a day if you didn't take any holidays. So the problem is absolutely massive. And source code is a very leaky asset. So you can think that, oh, well, this is private, but you're talking about the credentials that give access to all the inner workings of your organizations, your databases, your payment infrastructure. And if you think about who in your organization do you want to have access to those, it's a very small handful of people that should actually have access to those. But now if you think about who has access to your source code in the organization, it's huge. And there's no way of being able to distinguish that. So it's a massive problem of having these secrets in private repositories. So let's talk about some high-profile incidents that involve these. So I want to talk about Uber. So Uber this year had a massive breach. And in my opinion, it could have been so much worse, but I want to talk about exactly what happened. So a bad actor bought some credentials on the dark web for Uber's VPN, be able to access Uber's internal network. Now, luckily, Uber did one thing correctly, and that they had multi-factor authentication on this. So it was another challenging step for the attacker. But through social engineering and pretending to be the security team, they called up the person whose credentials they had access to, told them that it was an emergency, and he accepted the multi-factor authentication, and the attacker made it onto the network. So we already have the fact that these credentials made it to the dark web, which means they were exposed somewhere, but that's not where it stops. In a mature organization, just because they make it to your internal network doesn't necessarily mean that they should be able to kind of disrupt services or access sensitive information. But once they had VPN access, they started scanning Uber's internal networks to try and find more sensitive information. And they found some secrets inside some PowerShell scripts. So PowerShell scripts were just being used to automate something. So from what we've seen, what we can assume is that they had PowerShell scripts that when a new person joined the company, they would put in some permissions, and this PowerShell script would go through and create lots of accounts on different services for them. So how do they do that? Well, they had hard-coded the admin credentials to their PAM system. A PAM system is like your secrets manager and your password manager rolled into one. It controls access to every part of your organization. If an attacker gains access to this system, not only do they basically have access to everything, they can create accounts for themselves, which means they're properly authenticated and really, really hard to detect. And that's exactly what happened. So then from there, the attackers gained access to basically every single one of Uber's accounts, their cloud storage accounts, their email accounts, their threat detection. So they could have even shut down their threat detectors. Basically, they had access to turn off the alarms in the buildings, so to speak, to persist their attack. And that's all because they had poor secrets management. And going back to private repositories, well, we can look back last year when Twitch's source code was leaked publicly. So this happened because of a small misconfiguration. Basically, they were self-managing their version control server, their Git server. They made a mistake in the configuration, and all of a sudden, Twitch's source code was publicly available. So you think about, oh, my source code is private, doesn't matter. Well, here's obviously what Twitch's mentality was, but a very small mistake and the whole system comes down. So the attackers did a very big favor to Twitch, and they publicly announced that they had the source code and they leaked it online. Why did they do a favor to Twitch for this? Because if they wanted to be more malicious, they could have kept it, because inside that source code was huge amounts of secrets, huge amounts of credentials. We found over 6,600 exposed secrets in here, including 194 AWS keys, so keys to your cloud infrastructure. We found 69 Twilio keys, Google keys, and even Stripe keys, so keys for payment systems inside Twitch's source code. Now, had the attacker been more malicious, they could have taken these keys and sold them. Luckily, they decided not to. But here's an example of where the whole system can come down because of exposed secrets inside private source codes. And source code very, very often makes it public. There's been endless amounts of source code leaks this year from Microsoft, NVIDIA. There was a group of teenagers called the Lapsus group that were leaking source code everywhere. So, we can't rely on the fact that our source code is going to remain private. And if we just take one of those of how does a group of teenagers gain access to massive companies' private source code? Well, here we have NVIDIA. So NVIDIA had their source code accessed by the Lapsus group. How did that happen? NVIDIA is a great company, great security. In their private source code, they had signing keys that were used to sign malware. So, very critical keys. So how did they get access to them? This is Lapsus Telegram channel. They basically just paying people, insiders, to give them access, right? You don't need to have huge amounts of sophistication. You think about everyone in the organization that might have access to the source code, right? And now all of a sudden you find an intern, someone that just got fired, someone that's planning on leaving, and you offer them $5,000 to give them access to a Git repository. Well, it's probably pretty tempting for a lot of people. So we get a little bit technical now, but I'll kind of quicks over this. But the problem with secrets, and particularly with source code, which is kind of fundamental here, is that they're really hard to spot. Unless you know what you're looking for, unless you're an attacker and you're looking for them, just in general operations, they're hard to spot. So this is kind of what happens when we create code, right? You have our main branch, which is kind of the code that's running in production, and then you have these development branches that span off on it. Now, what can kind of happen with code is that we keep a track of everything. You hard code a secret, and then you delete it. It's in your history. And if you're working in teams, deleting your Git history, not only is it a pain, but it actually can be like hugely disruptive, so people don't do it. And even when we review other people's code, we don't review the entire history of a feature. We reviewed the latest version of that with the latest version in the main branch, which means that if someone did commit a secret, it's gone in the history and it's forgotten about. Hard to find in day-to-day operations, easy for an attacker to find. So how come this all happened? Well, basically, because we're moving so fast in development now. When we're creating applications and features, we're moving at the speed of DevOps, but we haven't integrated security into this process. We're deploying applications every day. We have all these third-party tools that enable us to move quicker. We're not making credit card processing, we're using Stripe. We're not building our own authentication, we're using Okta. All these different things, but it leaves the door wide open for, basically for bad guys to be able to find and exploit these secrets. So we have secrets that are committed for testing purposes. Private repositories are accidentally made public. We have secrets that are in auto-generated files and logs. We have sensitive files that are accidentally included in here. And we can accidentally push code to the wrong repository. These are all ways that our secrets, these highly sensitive strings, end into the wrong places. And what's really important is we have no idea what happens when they get there. So let's quickly talk about what we can do to actually start solving this issue. So what does it look like when an organization has a good level of maturity? So we've just talked about how secrets can end up sprawled everywhere. We've talked about how hackers find them and what can happen. But let's talk about what does it look like if we have good practices that enable our secrets to remain secure? What does that actually look like? So here we have, what we call our maturity model. And basically, if you take your organization or your industry, and you look at how you're going, what you want is you want to be at the top. You want to be in level 4, but most people are around level 0 or level 1. And so we've created these steps, like pragmatic steps of what it looks like to not only get to level 4, but actually to move there. So if you decide that, okay, you're a software organization and you want to be at level 4 of managing your secrets and having secure development processes, what does that actually look like? What does that actually mean? Well, it's going to be a process. You're not going to get there overnight, but there are steps that you can take in order to start moving towards them. So what we'll do now is we'll just go through these steps and what it looks like to be a mature organization and managing your secrets in a mature way. So let's talk about what does it look like if you have no maturity. So we've mentioned that, secrets in these different areas. So basically what's this mean is that you've got your developers, your software engineers, and they're basically storing these secrets in plain text. A developer needs an AWS key to connect to an S3 bucket or connect to the server, and you just send it to him. He stores it on his computer. He or she stores it on their computer in secrets.txt, and away we go. When we get to our actual private source code repositories, the version control systems, we have no checks and balances into there. So secrets are going to end up being committed in there, and we have no idea. So this is where most companies kind of start. We don't understand how much of a problem it is, and we're small enough to kind of get away with it for a small period of time. So then we want to get to really that level 1 area where we're just starting to think about how can we securely manage these secrets. So here we still have our secrets in the developer environments, and we look at our secrets management. Well, these are still being stored in unencrypted config files. Maybe they're not being purposely checked into our Git repositories, our version control systems, but they're still unencrypted on the developers' machines. That means that we still have no visibility over where these secrets are. And when we look at in our source code, okay, these are now grouped into areas. They're not sprawled everywhere, but they're still checked into source control, which means if an attacker gets into that source control, then they're going to be able to find these secrets. And if we go down here and we will look at secrets detection, because of course we would need to manage our secrets, but we want to be able to detect them if they're there. We might have some small detection in place. Maybe we're using some regular expression to be able to detect some of the patterns of these secrets in some high profile source repositories. But really, we're not got adequate detection in there. So we still don't know that we actually have a problem. Now, once we get to level 2, we're starting to actually achieve some maturity. So let's have a look at kind of what we want to have in place for kind of secret storage, secret detection at level 2. So now we're actually using some correct tools to store our secrets. We're using a secrets manager. That might be a vault, could be something else. There's lots of tools out there that we can use, to manage our secrets. So here we're first starting to see that these are actually kind of stored correctly. And this is really important because we can have access control over these and we can limit who actually has access to them. But we're also still seeing some secrets being stored in source control. And in particular, at this stage, people will say that they're encrypting their secret files and putting them in version control because that's an easy way to send it throughout your developers, throughout your teams. This is still a really poor practice because it gives you a single point of weakness, but at least they're not in plain text anymore. And then when we look at our detection, what are we actually detecting in our repositories? So here we have our critical repositories. So our production areas are being scanned at certain process, at certain triggers. So when we're making a pull request, we're scanning for these secrets. When we're merging into the master branch, we're scanning for these secrets. So we're starting to get some maturity in here. Now, this is kind of where most big companies are. If you look at the breaches that I talked about, this is probably where Uber is. This is probably where Twitch was. This is probably where CodeCov was. So you have some processes in there. We're not just storing secrets in Git, but we know that they're still going to make their way out. We know that they're still going to be in the history somewhere. We know that they're still going to make it onto our infrastructure. And that's because we don't have adequate fail-safes in there to be able to kind of prevent that. So we still need to go a little bit further ahead of that. So now if we get to level 3, we're starting to now get to a point where the risk of our secrets being exposed is starting to come down a little bit. So what do we have in our development environment? So yes, we're using vaults. We're securing these secrets in our managers just like before, but we also have rotation in place. We should be rotating our secrets very regularly because then if one does get leaked, it should be invalidated soon thereafter, just on regular rotation. So we've implemented some secrets rotation based on our secrets management. And we've completely stopped storing secrets in Git, unencrypted or not. We've removed that from our environments. That's a really important step to be able to get to. But it's actually quite hard because you're going to get pushback from your developers and software engineers because it's very convenient to be able to do that. And now let's move over to secrets detection. And there's been one big change, and that is that we're actually starting to detect secrets locally on our developers' machines. So we've talked about secrets being stored accidentally inside private repositories. Once the secret gets there, it's automatically compromised because it's going to be cloned onto multiple people's machines. It's going to be backed up. It's going to be pulled down, and we've got no visibility over it. Doesn't matter if it's been there for a year or a day. That secret is absolutely compromised once it hits your Git repositories. But so now we've got continuous scanning, but we're also scanning this before it gets to our Git repositories. So when your developer commits code, we can implement a Git hook that will block that commit, block that upload if it contains a secret. This is important because now we've not only just identified the problem by scanning our Git repositories and identifying that we have secrets in there, but we've actually started to stop the bleeding so we can move forward and start solving the problem. And then once we get to the expert levels, I won't go through all the stages. I'll just talk about pretty much kind of the few things that have changed between this. And that is one, we've got introducing the concept in the developer environment of dynamic secrets. So this is basically, instead of saying, I want to have a password or an API key for this service, we're basically creating one so that the machine can access it and then destroying that secret immediately. So that's what a dynamic secret is. That really reduces the risk of any secrets being exposed because they're one-time use secrets. That's quite a hard thing to manage. You need kind of teams to be able to do that, but that's why it's in the expert level. So that's really what we have. And then we also have our secrets detection inside all of our environments continuously at every stage. All of our repositories and all of our developers have pre-commit hooks to be able to detect these. So this is what it looks like to be able to sleep easily at night and not have secrets at risk of being exposed. But, this takes quite hard. If you're at level 0 or level 1, we're not going to get here overnight. You're not going to be able to find a security vendor, although I'm sure they will promise you that they can. that you'll be able to get there instantly if you just sign a $100,000 check. Doesn't work like that. We have to move forward. And there are other steps here that I'd kind of locked out because this was a half an hour talk and I didn't want to bore you all for 2 hours talking about all the things that we can do for secrets managers. But the first two are probably the most applicable and certainly the areas where the most amount of secrets get leaked out there into the wild. So now we have to look at kind of building detection and remediation programs, because now that we're not storing secrets and we're detecting them and we have vaults, we actually come to an interesting area where we're still going to have incidents. The big difference is that now we're actually aware of those incidents. When a secret does enter the version control system or the Git repository, we're actually aware of it. That's one of the big differences between now and kind of at level 0, is that we're not even aware of the problem back then. So remediating incidents is really hard. At the start of this presentation, I talked about the fact that in the average company, in the average repository, there's going to be 1,000 unique secrets, 13,000 occurrences of secrets in these repositories that we're going to have to sift through and organize with only 4 AppSec engineers. That's a massive task. So remediation and solving these issues become really important. Otherwise, it's just going to keep getting ignored. So we're monitoring our source control. We have lots of different types of detection. Yes, and we're getting alerted to them, but then what? Right? We're aware of the problem, then what? So remediation comes from being able to prioritize incidences that are most severe. We need to start doing things like validating our secrets. So if an AWS key leaks, do we know if it's a real AWS key or not? So we need to implement some of these factors in so that we can start prioritizing the incidents and taking effect of the ones that are really causing havoc at the moment. And then we also, and how do we kind of do all that? Well, we also need to integrate into the developers. So we have this concept of DevSecOps at the moment, development, security, operations team, and merging them all together. Why is that important? Because, developers are the ones, if they've leaked a secret, they're going to have all the context around what that secret does, why it's been leaked, is it valid? And we need to involve them in the process. And otherwise, we're just going to have isolated security and operation teams working on their own. So really important in the remediation process that we actually involve all the parties. We get the developers involved and we actually know where we're getting. And we also need analytics to be able to see the problems at a glance. Because the reason why this is such a massive problem in our security supply chain is because people aren't aware of this as a problem. If we scan your internal repositories of your organization, I can guarantee that there's going to be secrets in there. And it doesn't matter if you're building cloud services or you're manufacturing paint. You have software engineers working for you now if you're a large company. It's the way of the world. Every company is turning into a software organization. So we all need to be focused on this. And then we also need to be able to integrate detection into every area of the software development lifecycle. So we have here, going through from the start, we're creating our code all the way to where we're deploying it. Secrets can emerge into our supply chain at any moment. Obviously, when we're writing code, they can be hard-coded in and then we commit them, but they can also be injected just before our CI/CD runs. If our CI/CD environments get compromised, we can dump out the credentials there. And then even into the deployment process, we might have credentials for package managers running in those scripts. So we absolutely need to have secrets detection, at every stage of that. So there's lots of tools to be able to do secrets detections. There's some open source tools that you can use for free, like TruffleHog, Get Secrets, and there's lots of tools that you can use for secrets managers. Again, some of them are open source, like HashiCorp Vault, or some of them are really expensive, like the commercial version of HashiCorp Vault. What's important here is not necessarily the tools that you're using, but also that you are using them. So I work for a company called GitGuardian, and we have a bunch of free tools for secrets detection that help with that. But the important thing that you need to be able to do is actually make sure that you're using the tools to effectively combat this problem. So I'm just going to finish up on one thing. If we want to have our supply chain and our source code free from secrets, which we know is a massive problem, there's really 3 areas that we need to focus on: our processes, our people, and our tools. Right? We need to have the tools in place to be able to do this. But this is why I said vendors can't solve this problem alone, even though they're going to promise you that they can. It's because we also need to train our developers and bring together DevSecOps to make everyone aware of it. And then we also need to have processes in place of actually how to deal with these. What happens when an incident happens? When do we revoke secrets? What are our policies on rotation? And with this, we can start to combat that problem and build that maturity model of developing secrets. So that's at the end of it. There's a full white paper on this. So if you missed anything in the presentation, or you want to go deeper into different areas, this here is a white paper that you can download that will go through in much more granular detail all these elements. So if you were a bit confused about some areas, you can definitely dive deeper into this. And if anyone has any questions, I'd be more than happy to take them here. So thank you all for listening. Thanks.